Okay, great. Thanks for coming. The title of this talk was actually Frictionless Data for Research, but I just I'm going to be giving a sort of broader overview of frictionless data and hopefully show where applications to particular kinds of research data could actually slot in. So that's just to clarify a bit. And actually I'll be having Rufus Pollock here from Open Knowledge to kind of introduce data packages, as he's been working on data packages for a very long time now. So without further ado, I'll hand over to Rufus for a little bit, and
we'll go back and forth in the second
We'll go
part.
back and forth.
Yeah, it will be a tag team effort today. So thanks everyone, welcome here. Okay, so start off with just the home for this project is frictionlessdata.io. If you're wanting to kind of browse along with some of this, you can go to frictionlessdata.io, and this is the home for the overall project, which involves both the data package kind of specifications and the tooling and integration. Thanks a lot. So I want to start here by giving a really short kind of context about why the project came about and what the motivation is in what we're doing. So in general, it's like all the data stuff we do is in the service of some deeper goal, which is normally, to learn something, understand something better. So we want to reduce time to insight. We want to understand something. There's normally, some people just love data. They go home on a weekend and they're just like, I want to do stuff with data, right? But most of the time, we're doing stuff with data because we want to do something else, right? And that normally is, as I said, understand. It might be you want to understand climate change, or it might be you want to understand where does all your money go every month out of your bank account? Whatever it is that motivates you, there's something. And the thing is, there's a lot of friction. There's a lot of friction in using and sharing data in this way. For those of us kind of done this for a while, we all encounter this, right? Whatever you're up to. And so the kind of sub-goal is to remove that friction. So this project isn't so much about getting the insights, it's about providing kind of tooling and infrastructure that allows us to do that other stuff. And I'm just going to give an example to start with that motivates me. I don't know whether... So this is a real example. So once upon a time, I live in London at the moment, and sometimes Berlin. And I was interested in where the local authority, where government, local government spends its money, okay? And it's kind of awesome because, I'm going to both be here, thanks to the efforts of Open Knowledge, among others, we got the UK government back in 2010 to start publishing all of its spending. So not just its budget, but literally what it spends money on every month, like mobile phone bills, etc., which is great. And this is Greater London Authority. So in London, actually, there are about 26 different local councils, and this is one of them, which is it runs, if you've ever been on London, these are the guys who run all the underground trains, they own Transport for London. And the point about the story is, they publish CSV. I'd actually had a say in the spec, and so the spec was CSV. They published CSV every month, and there wasn't even a spec for it, and it was supposed to have like between 6 and 8 columns in that CSV, and the names of those columns were defined. And there's a reason for that, because they publish one every month. So generally, you're not that interested in 1 month of your local government spending. I mean, it's interesting, but it's not so interesting as having 12 months or 3 years of spending, right? You normally want to look at trends over time or who they spent money, who they spent the most money with. And they publish now actually about 85 different CSV files, one for each month they've been doing this. And at least at the time when I did this, and I actually personally did some of this data wrangling at the time, they, as it says on this page, they had 65 files and they had 25 different CSV formats. I mean, I use the word format loosely. What I mean is they structured the CSV in over 25 different ways across 65 files. So just to give you an example, this one, this is actually, it's not showing up maybe so clearly, but this is actually a column that's just empty, or if you're looking at the side. So they've got a blank column. And sadly, they didn't consistently just have one blank column. They would vary it. Sometimes they'd have, do you want to turn this back on? They would sometimes have 2 or 3 blank columns, or they would vary the amount of kind of informational metadata they added to the top of the file. Sometimes they'd have 2 lines, sometimes they'd have 10 lines. And I won't show you my favorite, but if you go to bad data, okfnlabs.org bad data page, which this is from, my favorite is a case where the woman publishing this data accidentally got a HTML 401 error and saved that as the CSV file. So you have an HTML page saved as the CSV file. including her name and login details and stuff. You don't have her password, but so we're very familiar with this problem, and this is part of the friction right now that goes on, and so this leads me, and I want to kind of explain that for the context, which we're all familiar with that kind of. We have extract, transform, load, but also share. What really was going on, really behind this, just to think back in a moment, it will be relevant for logistics. I'm not sure you can tell it in this one, but if you look at their data sets, you can tell they use SAP, because they have, sometimes, they vary by the names of these column headings as well, somewhat randomly across the files. They use SAP. So what's going on is somewhere in London government, some person who's probably not that technical, each month does an export from SAP, probably even maybe to Excel, maybe does something, saves it from Excel, and then puts it on their website. I mean, maybe they've automated some of that. And then that's one part of the logistics chain, and then you go and get that data and you try and import it into R, or in my case, Postgres, or whatever it is. And I want to do an analogy with the logistics. So you guys have phones or whatever, or you can think of your laptop, and it got made probably it was actually put together in China, probably, almost certainly, and they then put it on a truck, and they probably took it to somewhere like Shanghai, and they put it on a boat, and it maybe came to Rotterdam, which is a very large container port, or if it was in England, it would be Felixstowe. They unloaded it off the boat, they took it to the store, and then you bought it, right? And you can think of the logistics for data as a little bit similar. Right? So government, Greater London Authority collected data in their internal, financial system. They then cleaned it up and they had to probably clean it up. Vendors would send them invoices, and then they would post it on their site. They'd kind of publish it, and then you try to import it into your tool, and then you do analysis at the end. Just at the end, you use your phone. Eventually, when you've got data, you create insight, hopefully. Right? And this logistics chain has a lot of sources of friction in it, basically. Data's hard to find, it's not open, its structure's poor, etc. And I'm going to do my awesome tree map of all those problems, roughly of their size. You can tell I'm not a great visualization expert. And I'm just trying to explain that, part of the issue in data is this side, but there's also data quality. And the reason for just showing this tree map is open knowledge spends a lot of time on the pink area. But frictionless data is not about that at all. We don't care whether your data is open, closed, completely proprietary inside your organization. This tooling and process works either way. It's got nothing to do with open data. But it focuses on the right-hand side of the diagram, the data quality, interoperability, tool integration. And I just want to focus, again, on this analogy, which is, I actually want to start, I should have these slides the wrong way around, but basically, if you think about shipping, there's lots of things that cause friction. One day we didn't have trucks and we just had horses and carts, and that was quite slow transporting stuff that way, right? Really slow. And there's, it might be really difficult to fabricate iPhones, or it might turn out to be really difficult to use your phone when you get it from the retail store, or whatever the problem might be, or to get apps on it. But I want to really focus on only one part of this, because otherwise we kind of boil the ocean. And it's the loading and unloading, if you like, the analogy, and particularly loading and unloading off the ship. So here, there's a kind of load and unload step. There's a step where you get it into some system and then you get it back out. And the analogy I just want to remind is that this is what loading and unloading ships was like once upon a time, 50 years ago actually. People loaded ships by hand. And there was a solution to this. This is what it was like. It was very slow, it was very costly. And then they had this. We went from loading bananas by hand to loading them in containers and then loading them on ships very efficiently. And in a variety of ways, this has been hugely productive. Just to give you a sense, and this comes actually from Nick Stolling, my colleague who did an initial talk about this a little while ago. The thing maybe is just to focus on the bottom one, but the amount of tonnage you could load in a ship went up about 7,500 times. You got 7,500 times more productive at loading and unloading ships from moving from doing it by hand to putting them in this container. Now, there's a point to emphasize, and why this analogy I think is really nice, is someone still has to load the container somewhere. But there's a real efficiency from doing that elsewhere and having this standardized container for putting inside and outside of your kind of on and off your ship or in and out of your tool. There's often a place, maybe to put it for the data geeks here, because I'm going to come to the data point, often when you make a visualization, you do need to tweak the data. To make a good visualization, I think it's quite hard to automate. Maybe one day with AI we'll have automatic amazing visualization. But normally at that point when you're doing visualization, you do load it into your tool, but you normally do some tweaking. And similarly, the person doing the census, collecting the data in the household, they're literally saying, like, how many children do you have? How many people live in this house? At that point, it can be quite manual. But at the moment, it's this other point where it could be really automated, where it's not. And data, as I said, is shipping. So someone here, this data almost certainly came from a structured database. And this is the Bureau of Labor Statistics in the United States. This is unemployment data. And this is like ASCII. You've got merged cells over there, like employed in ASCII and stuff. Like, this is really, almost has to be manually re-entered. It's really painful. And so the core idea in frictionless data, at the heart of it, is basically a concept about tooling and automation, but also about a standard. And so just to show this picture again, there's two things here. What's really actually productive are the cranes in this picture. But the cranes couldn't work without the steel box. Like, standardizing on the steel box allows you to build cranes that can load a ship in like 24 hours. And so going back here, the idea is that data packages are this kind of simple data containerization, the simple steel box. And really, at that moment, there's kind of, I just want to maybe end before I hand over and we start looking at the tooling, at the key principles behind doing this. Having done, there's lots of stuff out there. So one stuff is that they're incredibly simple. Data packages are like the simplest thing that you could possibly have. They borrow utterly also from existing work. They're basically based on Node, NPM to a large extent, or packaging in software. They're very web-oriented. They're native JSON, it's CSV. They're focused on existing tools. And it's open. It's very easy to use. So at this moment, we should switch over and actually show you some stuff in action.
Cool. Right, so we talked about
You need to click present.
Yeah, right. There you go. Right, we talked about the steel box. I'm going to present to you the steel box and some of the actual cranes. So right in this picture you have some cranes at the top and some actual iPhones or bananas in the blue and the green. And I guess and you see some real work going on right now. So in this case, I'm showing some recent tooling, recent Python libraries we've been developing to work with data packages. And this example is pretty straightforward. I mean, what it does essentially is, after importing the data package library at the top there, you're essentially just giving it a location, right? And the location here can be on the web. Right now, this data package is stored on our sort of core datasets project, kind of community-run sort of repository of very high-quality datasets. And so you can just point to a location on the web or on your local disk, and you can say you can load a data package. You can load a data package object from that URL. And then, as you would typically do if you're using something like SQL Alchemy, you would create an engine to connect to your database. And then in this last line is where all the kind of magic happens. You're sort of pushing the data package using the descriptor file, which is, in this case, it's sort of described by dp.metadata, and we're pushing it into an SQL backend, just like that. Very simple. And so you can see that in this case, we have this SNP data set. The JSON table schema had described that the columns in that data set were date, S&P 500, dividend, etc. And it described the sort of type for each column. And all those type information was sort of like directly translated into, in this case, an SQL database, an SQLite database. But obviously any database that's sort of like that SQL Alchemy supports, it can translate to the sort of like native SQL types.
Can I switch you? I think one thing that would be useful to add is just for a moment to put up the GitHub source.
Right.
Can we do that for 2 seconds? And take the risk of running live. So if we put up github.com/dataset/SMP 500.
Yep.
If it will load, we will run the risk. So what I'm trying to get at there, so what happened is this data package is basically what's inside the steel box is a CSV file. It's your data. You can put anything inside the steel box. I think it's probably not going to load, is it? It's going to be naughty.
Yeah.
So you could put anything inside that steel box. Often what you're putting is tabular data. And this came, by the way, doing this came from myself doing years of data wrangling. I don't know anyone here who's done data, whether it's an R, whatever, you probably end up with CSV files or Excel files sitting around on your disk. But what's obviously missing often in, for example, CSV is the web not working.
Yeah, it's not working.
Okay. So let's just we'll go back here. So just, because we can even fast forward for a moment and come, do we have a screen? We don't have the screenshot of it, but that's okay. So just to say here, what you're getting is, you've got CSV automatically being loaded, and in particular, it's okay, thank you. Is it going to present now? No. It will? It will load. Okay, so in particular, what's particularly good here, and this is important to emphasize, is normally if you load a CSV randomly into SQL, you won't have the types correct. Like, you can do type guessing, and many languages do that, but by the way, if you've done type guessing for much time, you'll know that it's quite hard. So what the thing is data package JSON does is it uses that type guessing. It will automatically can create this stuff for you, but you can also edit it. So it's kind of CSV plus that minimal schema that you need to describe the CSV, what the types of the columns are. And you can add richer information if you want, but it's enough to do that to begin with. And so maybe we should talk about like making a data package. So there's an example where the point there is you've basically gone from a data package to something in your SQL database you could query in about 5 lines of Python. Okay, you want to do the main?
Yeah, and very quickly, we have a few minutes left. Here's an example, our example data. We have an integer in the first column. We have a string. We have a string in the second column. We have a float in the fourth column, and in this case, we have let's say a string in this last column. So in this case, we're just sort of like, we can use these same libraries to import a data package. We can add some basic metadata on the sort of high level of the data package. And then using our JSON table schema library, I highlighted the green, the most important parts here, where we're inferring the sort of like schema from the data. We can actually attach that schema directly into the data package so that that schema goes wherever the data goes. And here's an example. As you can see from here's the original data set, and here's the inferred schema here in the fields column, in the fields key right there. And so this is what your data package can look like. It's a folder with your data set, your data package JSON, and an optional README. And obviously you can publish this file, these sets of files, anywhere. Like in this case, we're publishing to GitHub, which actually provides a really neat sort of use case. Sure. We have a few minutes left.
We started. How long do we have left? How long?
I think about 3 or 4 minutes.
Okay.
So yeah, I mean.
Can I?
Yeah, go ahead.
So very quickly. So we've created you've created a data package. One of the other points about this is you can have your existing data, and you don't have to do anything to your existing data to make it into a data package. It doesn't. It's on the side. It's kind of progressive enhancement for data in that sense. Particularly the concept. So this is actually what it looks like on disk. In particular, the logic here is basically the spec is tabular data package, which describes tables, is data package which can have anything in its steel box, and tabular data package says you can only put tabular data in my steel box, in particular CSV, and you describe the CSV with JSON table schema. And those things plug together to make a data packet, tabular data package. And you get these fields. And then you can put this tooling on top of it. And we're just going to really be quick here. And you can also extend your metadata. That's the other thing. You could say, for example, I don't just want to have tabular data. I want tabular data which has these 8 fields in it, and it must always have this 8 fields in it. Or I want to describe restaurant quality data, or I want to describe anything. And you can have profiles of data package, like a fiscal data package, or a neuroscience data package. And I just want to give an example of what this actually starts making possible quickly, which is, for example, automated data validation. So going back to the example of the GLA, the poor lady, and I know her name because I read that 401 page, called Margaret Byfield, didn't have anything to tell her. She's doing her best job. She just doesn't know that that's bad CSV. So, for example, once you start having data package and JSON table schema, you can start doing very simple validations. We have this thing called goodtables.ogifnlabs.org, and it uses JSON table schema. You put in your CSV or you upload a file, and you get, for example, these kind of results. So, for example, here, it's checked this file with this schema, and you can reuse schemas. They're very, very easy to write. They're tiny bit of JSON, and it can tell you, for example, that that is not a date, that some date in the date of payment field is not a date. And you have a command line. And to finish with an example of then what you can, which is even nicer, is you can then start running that automatically. So, for example, if you're a coder, you're familiar with continuous integration, where you have those badges on GitHub repos telling you that your code, all the tests are passing. Imagine we have the same for data. So, for example, here, we've just actually done a demo using the tooling we've already built in Python and other stuff. You basically push your CSV file. Every time you push, you run some automatic tests, and it says, we've added some bad data here. I don't know, we don't have the screenshot, but basically it goes through and it will even report, just like we had on Good Tables, it will report something like that, but in the Travis report, it will say, your data failed its integration test, And by the way, it isn't just type checking. You can check, is it bigger than 0? All the numbers in this, we're spending money, we shouldn't have any negative numbers, or whatever. You can do that kind of stuff. And there's a load of integrations. The point about those containers, to go back to them, is that they allow those big cranes. What's really valuable about having the container is not the steel box, that's quite easy, but having the tooling around it. What it allows is a scale of reuse. So there's CCAD support, BigQuery, Redshift, SQL support already, where you can automatically get data package in there, but also publish from Python. There's libraries for Python, Ruby, MATLAB, R is in progress thanks to R OpenSci. And there's a bunch more coming along. So these integrations allow you to get data, the seamless interoperability with existing code and tools, and the frictionless transport, more import and export. And a final point is to just, what I'd like, and if people want to come up afterwards and we're running out of time, is to think about the user stories. So I demonstrated the containers allow you to do some stuff more frictionlessly, but what is that? And I gave one example was continuous data integration. Another example might be that I can model your data. You can describe your data. A constant thing you often do with users, particularly non-technical ones, is you need them to tell you, what are the columns? What are they about? Often you get data sets, you just don't know what the data is about. You can build very easy JavaScript HTML apps that export data package JSON and import it and allow you to do data modeling and description. You can do data editing. For example, I know My Society folks often have a lot of apps where you're basically just dealing with a big tabular list of, for example, elected representatives or, parliamentarians or other activity. And if that was described with a data package, it's basically CSV or JSON. If you described it, you could then automatically generate a very simple editor. So you could kind of immediately be editing with type validation and other things like that. It would be great to have a nice integrated CSV editor for GitHub. And finally, there's like Loadit that we've demonstrated, getting the data into a tool of choice very quickly. At the moment, R, if you're using R or Pandas or Ruby or whatever, all of these things will write their own lengthy libraries. If you look at Pandas, I think they've written about like 35 loaders we've got to finish. If we could start having that more generic, using the data package stuff, we would save a lot of work there and improve. That's it.
Thank you very much.